Yeah, zoom, zoom. Do we? And of course, I didn't see that student walk in 12 seconds after the bell, or the other one 30 seconds after, because that'd be mean. When you are done with this, if you got to empty your bladder, do it. I'm locking my door because it's idiot day. Okay? Senior's last day, there's always morons. That door will not open for another 74 minutes. So if you got to go, get her done. Y'all remember this when they give the girls crap for going to the bathroom together. Bummer. Is anyone still going? Did we all recognize? Did we bang that drum hard enough yesterday? What is this? Successive odds. It is my squares. Okay. It's a parabola. Well, the right side of a parabola. So I can say a sub, nope, purple colors. And say a sub 1 is -4. Switch to a sub 2 is previous term plus 2 by 2 minus 1. Switch to a sub 3 is previous term plus 2 by 3 minus 1. A sub 4 is previous term plus 2 by 4 minus 1. A sub 5 is thing plus 2 by 5 minus 1. Writing it all out for anyone who wrote it all out. And a sub 6 is previous term plus 2 by 6 minus 1. So, when I say a sub n minus 1 and I put in 2, 2 minus 1 is 1, so a sub 1 is that. Plug it all in and you get what? Okay. Put the previous term in. Now n is 3. I say -1, -1, 6 is... And you see that pattern. It's going up by 3, going up by 5, going up by 7, going up by 9, going up by 11. Okay? So whether you recognize the successive odds thing, the square numbers, or you actually plugged it all in, maybe even you plugged it in for the first like 3 and then you realized what the pattern was and then just finished it off. You would get those numbers. And your sixth partial sum, S sub 6, is, add them all up. There's 51, 62, 66, minus 165. The current age of retirement, by the time you get to be retired, it's going to be like when you're 71. But and don't worry, Social Security will be gone long before you get there. I also need the explicit formula, though. Oh, yeah, check my mental math. Brownie points are off today. Oh, did I miss my -4 entirely? Is it 61? Yeah, I just missed that entirely. Because 4 of the last 5 years, a disgruntled senior has specifically targeted me as an autistic and asthmatic person.
But that hasn't happened yet, so why don't we get...
Because it's happened 4 of the last 5 years, and last year our administration did nothing. When someone opened my door during a test and chucked something in like a grenade, hitting a kid who was taking a test, they saw on camera who it was and still didn't do anything. They just didn't care because our administrator hates me. So, I'm frazzled. I'm ready to actually punch things already. And okay, so writing the explicit formula. When I write the explicit formula, think about n was 1, 2, 3, 4, 5, 6. I know it's something squared, right? Because that's the successive square thing. So try, what is n squared? Well, 1, 4, 9, 16, 25, 36. How do I go from the square thing to those? How do I go from there to -4, -1, 4, 11, 20, 31? Subtract 5. And that's how you find your explicit formula. A sub n is n squared minus 5. Okay? So, our pointage. Some sort of work. The correct numbers, the correct sum, the correct explicit formula, one floating around for I did the dumb. Like, I called it 2n instead of n squared here, and it completely messed up my formula. Or I missed my -4 when I was making my sum. I added them up right, I just missed one of them. That kind of stuff. Okay? Anything? I only received one question last night, and it was honestly, I could find no fault in it. I think the answer key was just wrong. And I told you this book has more errors in it than the Pearson series. Like a minimum of 1 per section instead of 1 per chapter. I think they didn't pay their grad assistants enough to do the solutions to it. Maybe they were hungover. I don't know. 30? Okay. Womp, 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 womp. Womp, womp, womp. Okay, find S sub 8 of thing. I think this was actually the one asked. 400 was what you had, right? And the solutions don't have that? It was 428 in the solutions. Okay, so yeah, that was the one question was, I got this, where did I go wrong? I look at work and nowhere? Like, did you get 400? Oh, okay. Okay. Well, yeah, if they goof something. So I start with 1. Then I'll take previous term plus 18 minus that term. So I'm going to add 1 less every time. So the next time, I'm going to take 1 plus 16. The next time, I'm going to take 17 plus 15, because it's the third term. 17, 15, 22, 32. I'm going to take 32 plus 14. So 46, 56. Then I'm going to take 56 plus 13. Noise. Right? Because now we're at the 1, 2, 3, 4, 5 term. 5 add 13. Yeah. Okay. Then I'm going to take 69 plus 12. So 81. So each time, because n is increasing by 1, that means the thing I'm adding to the previous term is decreasing by 1 more. So I'm going to add 16, add 15, add 14, add 13, add 12. Take 81 plus 11. Take 92 plus 10. Wait, what am I supposed to find? 8? 1, 2, 3, 4, 5, 6, 7, 8. Oh, okay, cool. We're there. Add them up. So what's that? 150. 46? No. Because you had 14. Oh no. 4, 5, 7, 8. No. Okay. You got time. You'll get it. Okay.
If we don't, we still get time.
But no.
That's not how it works. If we don't get an algorithm, we're going to raise. Oh, let's go. There's no room on there. He's kind of over it. I don't blame you.
We'll get food out of you before me. Okay. But do you see it's putting in the n, putting in the n, putting in the n. You're adding one less every time because n is getting bigger. And then add them up. Assuming we can mental math. Normally, 10-2 is, if we really got our foot on the gas, we can get it done in a day. Otherwise, it's like a day and a quarter. Like we almost get done with it. That's why our schedule says 10-2 today, 10-2, 10-3 tomorrow, and then Friday will be the tail end of 10-3 with 1 or 2 examples from 10-5. And that'll be it. So, arithmetic sequence is I keep adding the same thing every time. That's what arithmetic means. I add the same thing every time. And I do mean add the same thing every time. Because when I add the same thing every time, I got to remember adding negatives takes the place of subtraction. There is no such thing as subtraction. Subtraction is a lie. Remember, we've been lying to you since kindergarten. Subtraction doesn't exist as an algebraic structure. Like you can't prove it because it's not bound by the same kind of rules like addition is. Addition is commutative, associative, has the identity. Okay, it's got all that fun stuff. So when I say that I'm adding something every time, even if the sequence is decreasing every time, you say I add a negative. Okay? You're going to want to write this down. I'm just going to leave it over here too, because we're going to keep referring back to it. A sub n, so the nth term is a sub 1, whatever the first term was, plus n minus 1 d's, where d is the common difference. Common difference is fancy word for the thing I'm adding. This is first term. This is number of terms. And this is the nth term. Okay? So, that's it. It's a formula, it's a definition. Arithmetic sequences and series are the that. I hope you can find the pattern in this. 17, 12, 7, what is the common difference? Okay, so if it's going down by 5 every time, I would say the common difference is negative 5. I'm not subtracting 5, I am adding a negative 5 every time. And then find the next 4 terms. I hope you can do that. Subtract 5, subtract 5, subtract 5. Oh, I can't. Subtract 5. Okay, that's it. Baby steps. What's the common difference? Find the next terms. Goo. All right, here we go, mental math. Is it? Yeah, it is. See, we can't even do mental math. Nope. Okay. So, negative 36, negative 5, 26, right? Yeah. Right? 31, 95. Yeah. Okay. This one, be careful. Your D is going to be negative. Make sure you actually say, I'm not subtracting a thing, I'm adding negatives. Okay. So 44, 13, 57. Subtract 57, 80, 73. Subtract 57, 16. Subtract 57, negative 41. Oh, I suppose that's not actually one of my numbers. That's my D. And then subtract 57, negative 98. Okay. Pretty straightforward, just assuming you're not cross-eyed or have high blood pressure. Come on now. I'm going to leave that there just to annoy someone. Okay. The explicit and recursive formulas. Like I said, recursive, super easy to write. Annoying to find the nth term. Explicit, a little more work to write, super easy to find the nth term. A recursive formula is as simple as a sub 1 is 12, because you always have to tell me where to start. And then a sub n is the term that came before it, and because it's an arithmetic sequence, plus d. Well, in this case, what's d? There you go. Plus 9. That's your recursive formula. And I have to stress that your recursive formula has to include a sub 1. I got kids who will just write this part. You have to include a sub 1 because a recursive formula depends on what came before it. If I don't know where to start, I will never know what came before it. So,
In this sort of squiggly bracket system you've made, do you at all like define the difference and then just say the arithmetic formula, what's the difference?
it's a sub 1 is number, a sub n is a sub n minus 1 plus d. You just plug in these two things.
I mean, like, would you also define d equals in the system?
No, because it's right there in your formula. Okay, now explicit, that's where that definition comes in. For that definition, we say a sub n is a sub 1. We already got it. Plus n minus 1 times d, and we just found out d was 9. That is the definition of an arithmetic sequence, of something that is repeatedly adding. You just got to clean it up. So distribute, combine like terms. Your explicit formula is a sub n is 9n plus 3. That's it. Distribute and combine like terms. Or you can go all the way back to like 7th grade. You would get the number chart, right? And next to it, you would say, how much is it changing every time? And then you would put it into y is rate x plus start. Well, I keep adding 9, plus 9, plus 9, plus 9. So that's my rate. Start is always when x equals 0. In this case, I'm starting at 1, so I don't have the 0. That means I have to go back 9 to find out at 0 what would it have been. 3. You did this back in middle school. Okay? So you can either use the formal definition or you can go old school and just, if I'm going 9 that way, back up 9 to find out where I start. Same difference. So, blah, 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 same thing, that guy. Recursive and explicit. I suppose I was kind of lazy on that last one. Actually tell me which one's recursive and which one's explicit. Even if you just have an R and an E next to them. Good enough. Well, you know that D is a negative 5. Or whatever it is, negative 12. I could swear you just said 5.
I said 12, but I nodded to your 5 because
Huh.
it's okay.
You know that the D is a negative number, but when you add a negative number, could you in the formula just write subtract? Yes. Okay. Because that's just simplifying the expression. Okay. That's it. Told you, the last chapter is just formula plug and chug. It's one of those things that if you don't know it or you never seen it or never one's told you about it, you have no idea, but as soon as you see it, you're like, yeah, okay, whatever. Okay. Think about that weird, odd fact that you just never knew. Like, more sexual assaults on humans are caused by dolphins than any other animal. If you've never heard that, you might get surprised next time you hop in the tank at SeaWorld.
I thought they were. Is that actually?
Yes.
It's true.
And the male dolphin's member has an actual bone in it, so they can injure humans. If that's one of those random things you don't know, you never know. But the first time you hear it, you're like, okay, now I know. That's this for math. Once you see it, you're like, oh, okay, whatever. Because it's not difficult to say, I need to be careful around dolphins. Most of the time they're friendly, though. They'll even protect humans from sharks. Like they'll swim around people who have been knocked off of a boat or on a life raft or something, and sharks won't come near them. It's really cool. But anyway, nth term. So now I'm going to use that definition. Find the 68th term of this sequence. Boy, would that suck with a recursive definition. How do I go from 25 to 17, 17 to 9? We keep adding a negative 8. Do you want to add negative 8 67 times to find that? Or you got the definition. The definition says a sub n is a sub 1 plus n minus 1 times d. Well, find the 68th term. So I don't know this, but I do know the first term. And now I know n. If they said find the 68th term, n is 68. And I can just look at these three numbers to determine d is negative 8. There you go. So 6, 7, 8, negative 480, negative 496, 25, negative 471. Samsonite. Always call before you dig. Or no, 511 is the road information one. What's the call before you dig one? 311? 811?
Yes.
Okay.
I just saw it.
Find the first term of the sequence for which? They tell me a sub 25 is 139. They're giving me this information. 139 is. Why buzz buzz? No buzz buzz. Screw you. I don't know you. A sub 1 rut-row, I don't know it. That's what they're asking. So plug in what you know, solve for what you don't. Do I know n? Because they said a sub 25 is 139. I know that the 25th term is 139. And they gave me d, 3/4. So 518 minus 131, 121? Question mark? Right? Because that's 24. 24 times 3/4 is 18. Subtract 18. So that's it. It's playing around with the formula. Go. Plug in what you know, solve for what you don't. It doesn't? 24 3/4. No, you're 24 times 3/4 is 18. 139 minus 18. You're messing with me, man. You're putting the negative button instead of minus.
Here's a minus.
What? No, dude, 25 minus 1. Why are you taking 25?
Because I was doing minus one after.
Order of operations. Parentheses. Please. please execute my deranged adolescent sister. Okay, plug in what you know, solve for what you don't. Find the 38th term of first term plus 38 minus 1 times d. d is plus 27. 38, 39, 39, 20 and 7, 600, 210, 810. 810, 29 is 180. 990, 56, 1046? Question mark?
37. Don't you have to subtract it?
And then subtract 29. 1046, 29, 1017.
You're at 9.
Samsonite. Okay.
You added the 29.
I don't know. Next one they say find d of the sequence in which. So now a sub 38. They give me. They give me a sub 1. I know n because it's a sub 38. And they want what the common difference is. Y'all remember literal equations, right? Not actually doing the math, but instead rearranging things. I have to subtract 75. And then I'll have to divide by 37. Calculator one-shot it. Good enough. We got. And because they started in decimal town, they set the precedent. If you want to say negative 0.5, it's okay. But negative 1/2, preferable. Okay, so plug in what you know, solve for what you don't. Write an arithmetic sequence that has 4 arithmetic means between things. I brought it up in here, and every time I bring up something geometry, I just kind of get blank stares. Do you remember doing similar right triangles? And you would compare like short leg to short leg to short leg. You'd compare this hypotenuse to that hypotenuse to that hypotenuse, and it was a bunch of ratios. And when you were doing that, you learned that A over B equals C over D, cross multiply, BC equals AD, right? And then you learned that these were called the extremes. These were called the means. And we were told you that you can swap your means and extremes at any given time. I could swap my means because A over C equals B over D still has the same cross products. It still works. We can swap the means at any time. When they say it has arithmetic means, they're saying the things between. If something has, Frank, there we go. If something has 4 arithmetic means between these two numbers, they're saying I have 4.3 blank, 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 then 12.8. That's what arithmetic means are. They're the numbers in between these two numbers. Just like those were the numbers in between the Jesus-fish ratio. So let's think about that in the formula. I know a sub n. I know a sub 1. How many total terms will there be? 6. I just don't know what the common difference is. And once you know D, you can fill in the blanks. So subtract that, get 8.5. 8.5 divided by 5 is 16.1. No, 1 point. Wow. No. Well, I just would have cut you off by now anyway. It's 3 a day. So, too bad. Add 1.7. Add 1.7. Add 1.7. Add 1.7. 0.1. Okay. Now that's one way to find it. Another way is you think about what did you do? I added D. I added D. I added D. So if I have 4 arithmetic means, then I added D 5 times. I can just say 4.3 plus 5 D's is 12.8, which is just the condensed version of the definition formula. Okay, you're subtracting 4.3 and dividing by 5. So it's either use the formula or common sense gets you an equation that's just the simplified formula anyway. Okay, whatever your jam is, you got to fill in the blanks though, because it does say to find the sequence. Write the arithmetic sequence. Well, I can't write the sequence if I don't know what that D is. Find the D and you can fill in the blanks. Now you're good. So, yeah, that's because we're on hand instead of magnifying glass. Yeah. Well, even if it's not the first term of the sequence, it's the first one you care about. And that idea of treating something as a sub 1, even if it's not, is going to come back to us in a little bit. Are we on slide 5? God, if we actually get through 10.2 today, there's a chance that we could do 10.2 today, 10.3 tomorrow, show you one example on Friday, and then just chill. Because really the only thing in 10.5 I care about is the binomial theorem. You've heard of binomial theorem before. We just didn't show you the actual theorem itself. Y'all remember Pascal's triangle?
Yes.
So what's that? Negative 36, negative 37.1 divided by 7. 5.3.
Yeah, negative.
Okay. So subtract 5.3. Subtract 5.3. Is it? That's 4.3. Man. 7.1. Now I'm just saying words and they're popping up in my writing. Okay. More. Gimme.
1.8, negative 3.5, negative 8.8, negative 14.1, and negative 19.4.
Okay.
Do we have to write that like equation at the end of that?
No,
Okay.
because you can recognize that if there's 6 arithmetic means, then negative 24.7 is 12.4 plus 7 of those changes. In fact, if you wanted to, isn't that a little formula that you can make? A sub 1, A sub n? Isn't that just the formula rearranged? That D is A sub n minus A sub 1 divided by arithmetic means plus 1. You can just do it like that. Okay. And this is where the entire branch of discrete mathematics comes from, is people looked at patterns like this and started applying algebra to it and determining a sequence, a series can be described by an algebraic function. I can use the algebra to tell you what's going to happen based on the pattern. And that's where you get into things like creating combinatoric probability. That's where the factorial came from, was discrete mathematics. Okay. So if you're into the how likely is this to happen, how many ways can this happen, is that even possible? That is discrete mathematics. Okay, in a very specific instance. So cool on formula plug and chug so far? Poke. Y'all remember successive differences? We did this back in Algebra 1 and 2. If I would give you a table, you'd find the differences, and if the first set of differences is the same, it's a linear function. If the second set of differences is the same, it's a quadratic function. If the third set of differences is the same, it's a cubic function, and so on and so on and so on. Okay, example would be if I gave you, what would that be? 3 cubed minus 28. I'm trying to mental math. Come out and stop me. 9, 2, 0. Okay, let's say I have that as a sequence. And I want to know what type of function it is. I start with, always work your way up the list, meaning start at a sub n and go back towards a sub 1, because you're finding differences. What is 26 minus 7? 7 minus 0? Oh boy. 0 minus negative 2 is positive 2. Negative 2 minus 9 is positive 7. Negative 9 minus negative 28. 19. The first set of differences wasn't the same. That means this isn't a linear function. So I do it again. I do the next set of differences. 12. Next set of differences. 5. Next set of differences. Negative 5. Next set of differences. Negative 12. Are they the same? No. So it's not a quadratic function. Do it again. Do it again. Do it again. That's it. Are they the same? No, so it's not a cubic function. And you would just keep going and going and going and going until they are actually the same. So you're looking at your successive set of differences. I'm bringing that up because the directions for these cheat and they just tell you, find it. Find the quadratic function that makes this. So I want you to at least see the successive difference thing. They just tell me, hey, it's going to be a quadratic. I know it's going to be a quadratic because 72 minus 56. 56 minus 42. 42 minus 30. You're starting to see the pattern. The first set of differences is not the same, so I know it's not linear, degree 1. But the second set of differences is the same, so I know it's a quadratic. If it's a quadratic, then I can find the quadratic model. And I can do it any number of ways. Way number 1, the very first way that we learned to find a quadratic model in Algebra 2 was, well, that's n and a sub n. That's, the first term is 12. The second term is 20. The third term is 30. The fourth term is 42, and so on. And a quadratic model is a x squared plus bx plus c, except in this case it's going to be a sub n instead of y. I've got a bunch of, not x's anymore, now that we're talking sequences and series, a sub n is a n squared plus b n plus c. And we just got a whole bunch of n's and a sub n's. Plug them in, and you're going to get, if I put in 1 here and here, I get a plus b plus c is 12. If I plug in 2 here and here, 4a plus 2b plus c is 20. If I plug in 3, I get 9a plus 3b plus c is 30. And just when you thought it was gone, 1, 1, 1, 12. 4, 2, 1, 20. 9, 3, 1, 30. Use your brain. What's a different way, without even 3 variable systems, that we have made a quadratic model from a table in the past? We're headed there. Rack your brain. That final's in a week. Remember when you came into this class, I said even if you didn't use the calculator as much in Algebra 2, you're gonna now. Well, yes, it's on the calculator. What? How do I go? Okay, we're getting there. I have a table of values. How do I make a quadratic model from my table? Yes, it is on the calculator.
Oh, it's just calculate,
Quadratic regression.
oh,
You didn't have to do all this system crap. You didn't do that in Algebra 2. We tried showing you that and kids freaked out. Dump this into your calculator. Put into list 1 and list 2, 1, 2, 3, 4, 5, 6, because they're the first through sixth term, and put the first through sixth term into list 2, go do your quadratic regression. Go do quadratic regression. Stat. Edit. Dump stuff in. 1, 2, 3, 4, 5, 6. Over 2. Where did we start? 12? 12, 20, 30, 42, 56, 72. Stat, calculate, quadratic regression. Except, we're going to write it this time, instead of y's and x's, a sub n is n squared plus 5n plus 6. Okay? And this is, again, we're trying to prepare you for like 3 different classes at once here. This is starting to lead into the discrete mathematics aspect of when you do functional math and discrete probability. Like you can take as a dual credit class, any of you who are planning on doing dual credit next year instead of just doing trig and calc here, you know that PreCalc counts as the 4th math to get the Regent Scholar to get into, no, you need Algebra 2 as a minimum for 4-year schools. Some schools will require a 4th year math, but a lot of scholarships require the 4th math, and PreCalc counts as that. And there's a lot of kids who will say, well, I'll just do the dual credit algebra, college algebra. And that's great. Remember that Algebra 2, PreCalc, college algebra. It's like Algebra 2.3. Okay? Why?
No, they put it on my schedule. I need to change it.
Dude. Okay. But there's a lot of kids who will try to take that and say that counts as my 4th math. It counts as half a math. So you have to take the dual credit college algebra and either stats or functional and discrete math. This stuff, where you start to relate algebraic functions into discrete functions in sequences and series. Yeah, don't ever go from, don't even go from Algebra 2 into business math. That's, no. Like someone just saw your name and was like, give him another math class. Okay, next up, 2 more formulas. 2 more formulas, and they each depend on what information I'm given. They're both to find partial sums. So if I know how many terms there are, and I know my first and last term, then it's n over 2 times a sub 1 plus a sub n. What does that look an awful lot like? Take the first term and the last term. Nope. Take the first term and the last term times n over 2. The little one and the big one, add them up, divide by 2. Midpoints. Okay? We have all of those for a reason. Okay? This is effectively taking the midpoint or the median and multiplying it by how many terms there are. Because if I take the median value times how many there are, think about this class. What if I said, what is the total years of experience in this room? I could take the median age of a person in this room times how many people are in the room. Okay? So there's that one, and sometimes I don't know what the last term is, but I do know what my common difference is. Two a sub 1 plus n minus 1 times d. Okay? So you got two different formulas depending on what information you're given. So look at each one of these and tell me, what information were you given? What do I know? I know a sub 1 is -5. What else? I can find d pretty quick. From here to here is 7. Cool. What else do I know? I know the nth term. But it's a sub n is 317. Do I actually know what n is? There's an ellipsis in there. I don't actually know how many there are. Go away! No. Okay. I want you to look at those two formulas. What do both of those two formulas have in common? They both require n. I don't know n. Good thing I have the formal definition of it, and I can find n.
They say they come in peace.
All right. Yeah. Okay. I know a sub n. I know a sub 1. And d. Go find n.
Someone told you that, and I'm standing out there. Yeah, it was locked. I tried opening it twice. I knocked. Okay.
Just like, well, they're persistent. Plug your stuff in and find n. Now that you know n, so what's that? 3n -7 plus 2, 319 divided by 7. 40, 28. 280. Lost it.
Where did it go?
Yo. What's n? Incorrect. It's a -5.
That's 47.
It should come out whole. You can't have part of a term. 46?
It's 47.
Oh.
Add 12, 329 divided by 7. 47. Okay. So once I have that, I had to do a little bit of a side quest for it. Which of the two formulas do I have the information for now? Both of them. Right? I have a sub 1, I have n, I have d, I have a sub n. So which formula do you want to use? First one smaller, I'll use that one. So now I'm going to say S sub 47 is 47 over 2 times a sub 1 plus a sub n. And now you will know what the sum of all 47 terms is. $312, $150, $156. You know what? I'm not even trying today. Nope. I heard a 332. 7,332. Oh. Okay. Contestant 2, what do I know? I know a sub 1 is 27. D is negative 13. And n is 28. If they want the 28th partial sum, I know n is 28. What do I got the information for? Second formula. Setting up, plug and chug. S sub 28 is 28 over 2, a sub 1, plus n minus 1 is 28 minus 1, times d is negative 13. Jam it in your calculator. Formula plug and chug. I missed a 2. Two times 27. There we go. I said, last chapter is just formula plug and chug. I see 24 kids for 24 seats. Nope. Negative 4,000 something? Or is Finn completely off kilter? Negative 4158? Go away, I'm teaching class. So, contestant number 3 involves thinking. Yes. Look at the sigma on it. I don't want the 28th partial sum. I don't care about the first 5 terms. I'm starting at n equals 6. That means I've got 2 choices. Option 1, I can do s sub 28 and subtract s sub 5. Donut problem, right? Find the whole sum, take away the part you don't care about. We've seen that how many different times with how many different problems in here? All the way from area to stick figure Steve sitting in the movie theater, subtracting that angle that he couldn't see. It's the same thing, just different formulas. If you're going to do that, you got to remember to find what this stuff is for whichever formula you decide to use. which formula do you think would be easier to work with? Smaller numbers, right? Or less numbers. So to do S sub 28, n would be 28, duh. A sub 1. How do I find A sub 1? How do I find the first term? Plug in 1. Put in a 1. 5 minus 17. Go find A sub n, which for S sub 28 is A sub 28. Stick a 28 in there. Okay. Do the same thing for S sub 5. This time n's going to be 5. A sub 1, if I plug in a 1, is still going to be negative 12. But now my A sub n is A sub 5. Right? If I'm finding the fifth partial sum, then the nth term is the fifth term. So I stick a 5 in there and get 8. Then, donut problem. Find the whole sum, 28 over 2 times negative 12 plus 123. Minus the sum I don't care about, 5 over 2 A sub 1 plus A sub n. Okay, that's the donut problem. The Doughnut method says if I'm not finding the entire partial sum, I'm just going to find both of them and subtract. What do you get? I remember? 1564? There's a different way that involves less writing, but a little bit of common sense thinking. And we all know that some of us fail in the common sense department. So, option 2 says, if I'm going from the 6th term through the 28th term, why don't I just treat the first term is my 6th term? So now I'll say that my A sub 1, big air quotes, is actually the 6th term. Shove a 6 in there. (30 minus 17). So I'm pretending that my 6th term is the first term, because that's where I'm starting my sum. Now my A sub n is still shove a 28 in there. But where I have to be careful, how many terms am I adding up if I'm only going from the 6th term through the 28th term? (23). Common sense. If I'm doing 6th term through 28th term, how many terms do I not care about? The bottom 5. It's 28 minus 5, not 28 minus 6, because I want the 6th term. So it's actually 23 terms that I'm adding up, because it's the bottom 5 that I don't care about. This is where I get a kid argue with me every year. They'll look at plan book, and maybe I'll say something like 21 through 63 every third, and I'll put 15 problems next to it. And I'll get a kid who argues, just friggin' argues with that. They say, what are you even talking about? See? Like 63 minus 21 is 42. 42 divided by 3 is 14. There are 14 problems. Why are you putting 15 on there? You're wrong. Brownie point. Now say, all right, get your fingers and toes there, Cletus. Start counting. 21, 24, 27. And sure enough, they get to 15. Oh, because you have to include that first one when you're subtracting. You want problem 21. You're not getting rid of problem 21. Same thing's happening here. So if you can make a note to that, to just remember, it's not 28 minus 6, it's 28 minus 5 to get my air quotes n. It involves a little more thinking, but now it's a lot less writing. Now it's 23 over 2, 13 plus 123. Jam it in your calculator and see if you still get 1564. Okay? So, more writing, less thinking. More thinking, less writing. Choose your destiny. Okay? Yeah, probably. Well, we don't have seniors in here. I was going to say that's probably a bad thing to say today because so many seniors are freaking out. There's like 3 kids in my game club crying last night. Okay, go. Get them. Yes, all 4 of them. Because they've all got different flavor. Some of them you don't know n, so you have to go find it with your side quest. Others you can just formula plug and chug.
I love scientists and information for like types of things. The types of fundamental particles that hold flavors. Like the electron flavor neutrino flavor.
It's left field for Finn. Dude. Just do the problem. I agree, it's interesting, but bruh. Like, what's that? 11, 7. D, N. N is 18 to 29. 679, 684 divided by 18. 684 divided by 18. So how about 342 divided by 9? So 114 divided by 3. 18 divided by 3 is 38. 38n? Okay. Okay. Question mark?
Everyone else agreed. What do you agree? Why are you looking at me like that? That is right. There was no question mark. Is what I meant.
Okay. And then a sub 1, a sub n, d equals negative 18. Now you got a choice. Most of us are choosing this one. First one, what do you got? I heard a negative 4636. Yay? Nay? One bobblehead? Two bobbleheads? Okay. Contestant 2. Whoa, that's a negative 19. 19, 23, 32, 42, meaning of life.
Hold on. Can you describe
Hmm?
one of 42? Meaning of life is 42.
Hitchhiker's Guide to the Galaxy. They ask the aliens what's the meaning of life because they're supposed to know everything. And they say 42, and they, what the crap are you talking about? And then they just start laughing at how stupid humans are because they don't understand why it's 42. But then they never explain why it's 42 in the book.
Nice. What book is this?
Hitchhiker's Guide to the Galaxy. After Earth is destroyed and people have to go spread out among the stars. Yeah. Like the aliens take pity on humans and they give them the Hitchhiker's Guide to the Galaxy. So, what do we got for 6B? No, nothing. I heard a 6821 and I see one bobblehead. They're bobbleheads that usually get things right, though. Okay. Let's just get through 6C and we'll actually start with 6D tomorrow. That'd be a good place to pick up tomorrow. Well, then, yay for you. Like, woohoo! If you are willing to do the little cheater method here, there's 37 minus 22. There's 15 terms is my n. 46, 49, and a sub n, 37, 60, 74, 77. We're 977, so 5, so it's 110, 126, 2, 63, 15, 630, 300, 930, 940? Or is that another Samsonite? 945? I missed one? Crap. Okay, I'll start with 6D tomorrow. Are y'all okay with this? Pretend it's the first term. Okay. You just have to remember to take away 22 instead of 23 for your number of terms. Okay. If you don't like that, the Doughnut method always works. 37 partial sum minus 22nd partial sum. Okay.